Good afternoon, folks. This time around, it's extended mathematics, so we are covering number patterns. Going to be interested in concepts like the nth term. We'll look into linear, quadratic, cubic, exponential sequences. I think that's all we might be interested in for this level. So let's have a look at what we have. Right. Here, that's the topic. It's nth term, linear, quadratic, cubic, and exponential sequences. Now, we are given a definition here. Say, if we talk of a sequence, it's an ordered list of numbers which follows a predefined or specific rule. Now, to find a type of sequence, if it's linear or arithmetic, we look at the first difference, just to be constant. Now, if it's quadratic, then we'll look at the first difference. Then after that, we go to difference of the first differences. If it happens that is now constant, then we classify that as quadratic. Then with cubic, quadratic, it was the second difference has to be constant. Now with cubic, it's the third difference that has to be constant. Now with exponential sequence, the one which is normally referred to as geometric, we need a common ratio, which is the number that we use to either multiply or divide consecutive terms, giving us that value be constant, but we can use it to multiply or divide for us to grow the pattern. That is geometric. So we're going to try and investigate that in the given sequences. Right, so here we are required to find the nth term. So if it is arithmetic, then the nth term is defined as, Tn, we define it as n minus 1 multiplied by the common difference plus a, the first term. Let's have a look at this. We're going to investigate 4, 9, 14, and 19. If I look here, the difference is 5, 5, 5. Therefore, this rule works, but then we're going to simplify to say, if we want the general rule or the nth term, then we just take the unchanging difference, 5, we put n next, but n is the position, so we're going to test with the first position. Say when we have 1 for the position, it's going to be 5n, that's 5 times 1 gives us 5. But on our position 1, actually we have 4. So we either add or multiply a certain value for us to reach what we have on our pattern. So for this case, we've got a 5, but we want a 4. So we are definitely going to say 5 minus 1. So here is minus 1. That's the nth term. Then I'm moving to the next pattern where I'm given 7, 15, 27, 43. Let me try and check. Here is 8, and the difference here is 12, and it looks like here, I think it's 16. And when we continue, it looks like this time around it's now 4 all the time. So this one is quadratic, and with quadratic, we follow the general form. Tn is a n squared plus bn plus c. And what do we do? This part here is equivalent to 2a, implying that our a is actually 2. But this part here is equivalent to 3a plus b. So I'm saying I'll do my calculations maybe somewhere here. 3a plus b is equal to 8, but my a I got it is 2. So 3 times 2 here it gives us 6 plus b being equal to 8. Therefore, my b is actually 2. Then for this first term here, a plus b plus c equals to what we have on the first position. So if I say a plus b plus c, my result is 7. But a I got it as 2, b as 2, therefore c will now lead us to 7. So c is actually 3. When I come to my formula here, I'm saying Tn is equal to, because I got my a was 2. So that's 2n squared plus b, I got it as 2 again, so it's 2n plus 3. I'm substituting for these values. So that's my formula for the nth term. Then the next one is 2, 8, 18, 32. So if I check the difference here, it's 6, and there it looks like it's 10, and there 14. And when I go to the next set of difference, it's going to be 4, 4. So whatever we see, because we're classifying or finding the nth term, we did the nth term on question 2. So I've got the set of differences. What I know is this will be equal to 2a and this part will be equal to 3a plus b, and this one here is actually a plus b plus c. Then we do like we did on the previous question to find the values of those variables. We substitute them on the general form, it gives us the formula. So this is just a quadratic sequence. 20, 80, 80, 320. Now this one looks like it fails to be arithmetic, quadratic, or cubic. When I inspect, it looks like here, if I multiply by 4, multiply by 4, looks like that's how the pattern is growing. So for this one, which is geometric, the general form is a r to the power n minus 1, where a is the first term in the pattern. For this case, we have 5. So in essence, I'm saying my Tn is equal to 5 multiplied by, but the ratio that I got, it was a 4, so it corresponds to r here, 4 to the power n minus 1. I think that's my formula. Then I'm now on the fifth question. We want we are given the nth term rather, so we know the formula is 3n minus 2 to grow the pattern. So we are interested in n equals to 12. That's our position 12. So this is going to be given by 3 times 12 minus 2. So 3 times 12 is actually 36 minus 2. It gives us 34. Then moving to number 6, nth term is known, is 2n squared minus n. So we're interested in n equal to 7. So it's going to be 2 multiplied by 7 squared minus 7. When we do our simplification, it looks like this is going to give me, well, 7 squared, that's, I don't know, we can choose to factor 7. So we end up having 2 times 7 minus 1. And when we do so, is 7 times, this is 14 minus 1 to give us 13. And from here, we will now get 7 times 3, which is 21 carried 2, and 7 times 1, I think our result is 91. Moving to seventh question, identify the sequence. So you just want to test, is it arithmetic, quadratic, cubic, geometric, you name it. So it looks like this one here. I don't know, it looks like it's, because if I look at the positions themselves, if I say 1 squared plus, wow, not plus, then the second one is 2 squared, 3 squared, 4 squared. So it looks like the highest power there is a 2. And I think my general formula here will be Tn equal to n squared. So this is quadratic. So we just identify it's a quadratic pattern. Moving on, is this sequence linear? So we're being tested, we find a common difference there. So it's 10, 13, 18, 25, 34. So if I check here is 3, there is 5. Automatically it fails. So this is non-linear, right? Now we are on number 9. Well, I think there were 8. So done with our questions. That was basically understanding of arithmetic, quadratic, cubic, and geometric or exponential sequences. That's all that we may find under IGCSE Extended Mathematics. Thank you, folks.